Welcome back to the channel. So we're going over CCNA objective. We're going to talk about TCP versus UDP today. First of all, I want to make sure that any opinions expressed in this video, you know that they're my own and they're not necessarily reflecting the opinions of any employers I have had, do have, or will have. So I just want to get that out of the way very quickly. So before we get into the whiteboard and I start writing things here, I just want to show you this meme. And this is one that I have used for years when it comes to teaching TCP versus UDP. And hopefully it helps you remember and kind of, um, kind of gives you a visual to hopefully remember again that difference between TCP. And the purpose of this here that I want to kind of drill into your head when you start having questions about all the different details we're going to go over, they all boil it down to this one thing. TCP is going to be very deliberate and is going to make sure that everything is transmitted. UDP is going to be very flippant. It's going to send the data, it's going to hope it gets there. Some data may, some data won't. It's not going to worry about it. And that's the core of the difference between TCP and UDP. Hopefully you don't go, okay, that's all I need to know. You close this video. Hopefully you continue on, and I'll give you some more details of how we're able to implement those features that we want for the different use cases with TCP. The one is not inherently superior over the other. They have different use cases. And that's why we have them both, right? So, when it comes to differentiating the two, it's not a battle of who's the best. It's when do we want to use each one and why would we do that? So go ahead and grab a marker here. And the first thing that I want to talk about is speed. So TCP generally is going to be slow. That's because, again, the reliability that we have, the very deliberate nature of TCP being slow is going to be just kind of a caveat of that. And UDP is going to be fast. And one of the things that I want to mention about this is we're slow because we have more in the header. We have less in the UDP header. Right? So to provide that reliability, we need to put more in our TCP header than our UDP header. And before I get too deep into this, I forgot, I meant to mention this at the beginning of the video, but we are at layer 4. This is the transport layer, right? So we have the IP technology, we have the Ethernet technology that we're building on, and we're going to decide at this point if we're going to provide some reliability, we're going to provide some speed to our traffic. Now, today we have some other technologies that are coming out like Quick, which was originally developed by Google. And really the goal with Quick is trying to get the quickness of UDP with also the reliability of TCP. They're also doing some things like encrypting the packet header, which I think is dangerous for a lot of enterprises because it really puts a damper on some of the security practices we can put into place. A lot of businesses are actually going to deny Quick traffic by default. And you'll see that in most firewalls. So I believe that from a Fortinet perspective, from a Palo Alto perspective, that is the case. Not 100% sure on Cisco, but I would assume it's the same, that by default we would block Quick messages because we can't get the features and function we want in an enterprise network with Quick. However, for your home use, a lot of times Quick is going to be enabled. And they've implemented the technology in such a way where we fail back over to TCP if Quick is not supported. So we're talking about layer 4 protocols. We're building on those things. And a common misconception I want to talk about with TCP and UDP is these have nothing to do with unicast, multicast, or broadcast. These technologies are all unicast, right? So if we're talking about multicast or broadcast traffic, that's handled at layer 3. That's handled at our IP, whether it's IPv4 or IPv6 layer. So really, when we're talking about these, we're not going to worry about if it's multicast or unicast or any of that stuff. So just keep that in mind here when we're talking about these two. So TCP is going to be session-based, or connection-oriented is another term used, and UDP is going to be sessionless. right? There is no session with UDP. So if you ever hear someone talking about sessions, and I've got a video out there on sessions that hopefully is there to enable both aspiring IT professionals and IT professionals in the industry. I'm going over some of the things that I've seen in the industry that I think is kind of lacking in terms of knowledge. And so, hopefully, I think a lot of that that lack of knowledge is because lack of instructors doing a good job on this particular idea of sessions. Or some of it may be that people are absorbing so much material, right? They're studying for their CCNA. You're not going to get all of that. You're not going to remember all of that. Maybe little things like sessions, for example, are going to slip through the cracks, and you're going to be more focused on some other things that you see over and over again, or maybe things that you expect to be on the exam, and maybe you don't expect a complicated session thing to be on the exam. Now, in the real world, understanding sessions, I think, is really valuable. Again, I'm just going to say that I think my video is obviously the best on sessions. You should definitely watch it. But anyway, going back to TCP versus UDP, there's a lot of technologies, and I'm not going to get into all of them, that make TCP reliable that aren't on UDP, right? So, when we talk about flow control, we talk about, error checking and stuff, there's going to be light versions or no version on UDP. And again, I'm not going to get into that because I don't think that's going to be super valuable to you guys. But really just understanding that if I can look at a technology and go, okay, well, is this for reliable traffic or is this for sessionless traffic? Traffic we don't 100% care if it gets to the end. Now, if you're looking at stuff like error checking, right? That would make sense for the traffic we want to be reliable. But the traffic we don't need to be reliable, do we really need to do that much error checking? So one of the interesting things here that I find pretty common as well, a misconception that I'll dig into, is DNS. So it's always DNS. DNS is always the problem. DNS is actually TCP and UDP. And I've found that this is confusing for a lot of IT professionals that I've come into encounter with specifically. And I want to hopefully, just very quickly explain to you why DNS uses both TCP and UDP for very different applications. And we can use this to our advantage when we're doing some network configuration and maybe we're evaluating network traffic. The TCP, when we're talking about DNS, this is going to be replication traffic. This is only going to go between DNS servers, which means if we're seeing this TCP 53, right? That's the port we use for DNS. We're seeing TCP 53 going out to the internet. Maybe we should be a little bit concerned about that. That's not super normal. Whereas if we see UDP traffic, this is for client requests. It doesn't need to be super reliable, right? When we're doing replication, we need that UDP traffic to be reliable, or DNS traffic, excuse me. But with UDP, we don't need that to be super reliable, right? We can send the message again, no big deal. And so we'll use UDP port 53. Now we could use different ports when we go from TCP to UDP if we wanted to, but for the sake of simplicity, somebody had a brain when they were thinking about this, and they just used the same port number. But you'll see some examples of protocols where maybe they'll use one port number on TCP and a different port number on UDP. It really just depends. The other thing that I want to mention just quickly, of course, TCP, we have those sessions. Three-way handshake is a thing for TCP. One thing to remember, there's no such thing as a three-way handshake for UDP. There is no handshake. We just send the data, right? So again, it's going back to that fast core principle of UDP versus the reliable core principle of TCP. The other thing I want to talk about quickly is port numbers. So port numbers are kind of arbitrary. Some of the port numbers may change, right? You may have some applications that use several different port numbers, have random port numbers. You might see stuff like if you go and dig into the network traffic, your source port number and your destination port number are going to be very different. Your source port number is probably going to be something, in the 20,000 range, 21,568, and then you'll have a destination of 53. Now, why do we do that? That's because this needs to be a unique identifier to our endpoint. If we're doing NAT, right, that needs to be a unique identifier to our router so that they can essentially say, this is where the traffic is supposed to go. And then this needs to be recognized by the end server. So just keep that in mind, right? So our machine, say we're doing HTTPS traffic, right? We're just doing web traffic. We may be going to multiple websites at once. We can't use the same port multiple times. So what we're going to do is we're going to use these uncommon ports they're referred to in kind of these higher ranges. And we're just going to kind of randomize those. And then they can all go to the same destination port at different servers. We can't use the same source port for different sessions. Same thing over here kind of with UDP, right? We need to keep track of that traffic, what application that's going to, right? So we could have multiple UDP streams, and we want to make sure that, maybe one live video is going to one TV and one live video is going to another TV. We want to make sure that we know which one it should be going to, right? And then I just want to briefly talk about kind of the end use cases, right? So, this is all well and good, and going into the tech and the nitty gritty is all well and good. But I want to show you some things that really, like, what does this mean in the real world? So, TCP is a great example of HTTP or HTTPS, right? So we want to load all of the data on our web page. We want to make sure we have all that data. We want to make sure that, we loaded all of it, right? We want to see all the product information when we're going looking at something online. We want to see all of the blog posts. We don't want to be missing letters or words. We don't want to be missing, definitely not paragraphs, right? So it's really important that HTTPS is reliable. UDP, for stuff like VoIP, right? Phone calls, right? So if for some reason my voice drops when I'm talking to you on a phone call, and then I reconnect, do you want all of that voice traffic that I was saying while I was waiting for it to reconnect to all be retransmitted, maybe out of order? Or do you want to just forget about that and we'll start over? Really, for anything live, like a voice conversation, if you're doing a live stream, right, you're streaming maybe a sports match, maybe you're streaming a Twitch game, stuff like that, UDP is going to be your best bet here. TCP, is going to be for when you want all that data. Now you get into some gray area when you're talking about like video streaming. Typically you'll see that in TCP, but you may see that in UDP in some places, even if it's not live. So really, this is the choice of the developer. And another thing that I want to mention, since I said choice of the developer, TCP has a technology called sliding windows. The TCP sliding window is going to allow us to dynamically adjust how much data we're going to send at one time to be able to do that based on the reliability of the connection that we have, right? So when we're talking about the internet, I have a service provider. They're going to go to maybe a higher tier service provider. And by the time I actually get to the cloud or wherever I'm going to, I might go through 5, 10 different networks, including my own, before I actually get to the destination and back, right? So a TCP sliding window is going to adjust and basically get our, we're talking layer 4, we're not talking packets, we're talking segments. That's our datagram. Make sure that our segments are growing to the optimal rate until we start dropping those segments. So when we see that those segments aren't acknowledged, then we're going to actually reduce the sliding window. We're going to go back to what was reliable, and we're going to stay there. So what this does is this takes the onus off of the application developer for how big his segments should be, whereas UDP, there is no mechanism for acknowledgement. There is no mechanism for any of that. And so UDP, the app developer, is actually going to define how large they want those segments to be. So this gives some more flexibility to the app developer, but you could have mistakes, right? Maybe an app developer develops a UDP protocol for a perfect network, right, and doesn't implement it with any sort of checks and balances when it comes to segment size. And so you may have some really large segments going on in your network that maybe some of your older technologies aren't going to appreciate very much. But keep things like that in mind. These are some of the things that maybe an application developer is not going to know all the details of, because they're going to focus most of their education on programming, right? They're going to focus their education on whatever language, whether it's Java, JavaScript, C++, whatever they're programming in. and not so much on these protocols. Maybe they'll know a little bit, right? And hopefully they do. Maybe it'll be a very large team where they have a completely different team implementing the protocols than actually doing the programming and stuff like that. But keep that in mind that depending on which protocol we're using at layer 4, that there could be some difference there. I think that's really all I have to say about that in a very short period of time. Again, I would highly recommend that session video. And yeah, that's it. Remember, a port on TCP is not necessarily the same thing on UDP. They may be totally different protocols. Uh, so anyway, with that, I'll see you in the next video, and thank you for watching.